Okay, good morning, ladies and gentlemen. This is Professor David J. Delosreyes. I will now be discussing unregulated linear power supply. The power supply that I am discussing right now is the one that I have assembled many years ago when I got my, when I operated my electronic shop troubleshooting. This unregulated linear power supply is the output of this one is unregulated, meaning when you try to connect a load at the output terminal, it's either that it will go down. The output should go down and it will not stay at a certain value. That's why it's unregulated. So for this morning, I will be discussing why it is unregulated. It is unregulated because the output is not fixed at a certain value. For the regulated power supply, we got still another component at this terminal here. It is the so-called voltage regulator. And there are many types of voltage regulators. There is the so-called 5 volts voltage regulator. There is the 9 volt voltage regulator. There is the 12 volt voltage regulator. So since the output terminal don't have a voltage regulator, we could say that the power supply is unregulated. Okay, because when we try to connect a load here, of course, the voltage here that will appear, okay, will go down. It will not stay at a certain value. Unlike if there is a voltage regulator on this portion here, if the voltage regulator is 5 volts, okay, even though you'll connect a load, that 5 volt will not go down. It might go down a little bit, but not so much. But it will try to stay at that value, 5 volts or 12 volts or 9 volts. Okay? So I will now try to discuss the components of this unregulated power supply. This is just the simplest one. I just assembled a half wave rectifier, and the schematic diagram is this one. This is line number 1, line number 2, connected in series with line number 1 to protect the transformer. There is a fuse here because just in case there is a short inside the transformer, okay, to prevent fire, there should be a fuse here. So we place a fuse here. On the secondary side, of course, the input voltage here, I am here in the USA, in California, so the input voltage here is 120 volts. On the secondary side is actually step down. The voltage is around 20 volts, something like that. In series with this first line here is actually our diode, and this diode here is used to rectify current. It will only allow current to move in the positive direction, on the positive alternation. In the negative alternation, current will not pass through. That's why diode is just like acting as a one-way switch. That's why diode used to rectify alternating current to become a direct current. Okay? Connected here is actually an electrolytic capacitor. Okay? The purpose of this electrolytic capacitor is to smoothen the output of the rectifier, because without this capacitor, of course, the wave of the pulsating current will be a very rough one. So with this, okay, it will try to smoothen out the pulsating direct current. Okay, this terminal here is plus and this is minus. So if you try to use this one for charging any battery, you could use this one. Just connect this plus here with the plus terminal of the battery to be charged. Of course, the battery should be the chargeable one, and the negative terminal should be connected to the negative terminal of the battery to be charged. Okay, so this is actually the schematic diagram. This is the simplest form of unregulated power supply. It just contains one diode, one electrolytic capacitor, and one step-down transformer plus a fuse. Okay, and if I would like to show you the components now, this is the plug coming from the utility line. Here in the USA, the input here should be 120 volts. It goes here, okay, in series with one of the lines is the fuse to protect for any short circuit that will occur inside the transformer, just in case there will be a short circuit inside. So this is the primary side. The secondary side is this one, the green one and the red one. So actually, this is the diode now. That's the diode. Okay. This is the anode. The one with the white band is the cathode. Okay. This should be connected. The cathode should be connected to the plus terminal of the electrolytic capacitor. The cathode, okay, should be connected to the plus terminal. This is the plus terminal. Sorry for that. It should be like that. This is the plus terminal. This is anode. This is cathode. Okay. So the cathode should be connected to the plus terminal, and the plus terminal of the electrolytic capacitor is this one. The negative terminal is the other one. Okay. So this positive terminal of the electrolytic capacitor, which is connected to the anode or cathode of the diode, okay, goes out, and the longer one represents the plus terminal. I make a code that the longer terminal is the plus terminal, so I don't have to, mark it as plus or minus. For me, when I when I assemble this one, I make it a point that the longer one will be the plus terminal and the shorter one will be the negative terminal. This negative terminal emanates from the negative terminal of the electrolytic capacitor. Okay. Okay, I will try to bring out an electrolytic capacitor so we can visualize it. Okay, this is an electrolytic capacitor. The one with the band is actually the negative terminal, and the other one without the band should be the positive terminal. So this is actually the positive terminal, and the terminal that corresponds to the band is actually the negative terminal. That's an electrolytic capacitor. The purpose of this electrolytic capacitor is to smoothen out, okay, the pulsations of the output. Okay. If the output will be rough like that, okay, it will be rough like that. By adding a filter capacitor, it will try to smoothen out. Okay, so the purpose of this one, it's just like a reservoir of a DC voltage that is in the negative alternation. Instead of we are measuring a voltage on the output, there should be an output due to this electrolytic capacitor. Okay, so that's an electrolytic capacitor. The one here is same as this one. Okay, so this is the one with the negative terminal, and the other one with the band should be the positive terminal. So this is the negative terminal, and the longer one is represents the plus terminal. Okay, so this is the negative terminal of the electrolytic capacitor. The one here is same as this one. The one here is same as this one. Okay, that's the simplest unregulated linear power supply. The output of this one is actually 20 volts. Okay, if I would like to show you, okay, I will try to connect my what do you call this what do you call this I will try to connect the red with the positive terminal. Okay, I want to show you that the output of this one is actually there is still you see that one, the output voltage is 9.89 voltage, even though what you call this the outlet is not yet plugged. Where does that voltage come from? It emanates from the filter capacitor. Okay, so it's not yet discharged, so there's still a voltage. So just in case we want to, we plug this one, okay, then we switch on. So it goes up to 21.77 volts. Okay, just to show you that there is a residual voltage here, I would like to remove this one. I will shut it off. And you can see that the voltage at the output, there is still voltage. That's why we are telling viewers that if there is an electrolytic capacitor here, don't ever try touching this one, because there might be a residual voltage. For this one, it's not so high enough, but supposing that voltage is 400 volts and you happen to touch that one, so you'll get electrocuted. For this one, the plug is off from the outlet, right? And as you can see it, the voltage is still 21.72 because we don't have any load. This electrolytic capacitor is already energized. There is a charge on it. So for it to become zero, there should be a voltage connected across it. So it will take a long time before this voltage will drop down to zero. Okay? If you would like the voltage to drop down to zero, try to short out the terminal, but that's very dangerous. We might damage something on the transformer. And the best thing about it is you try to get a resistor. Okay? You try to connect it on the terminal to zero out the voltage and the electrolytic capacitor. Okay, that's it, guys. This is an unregulated linear power supply. Okay, it is unregulated because just in case we put a load on the secondary, the voltage will drop down, okay, to a certain value. It will not stay at a certain value, like if there is a 5-volt voltage regulator on the primary side, okay. Even though you connect a load, it will try to maintain that voltage to 5 volts. That's why it is so-called the regulated power supply. But for this one here, if we try to load this one, if the current is a little bit high, of course, it will not stay at 21.52. It will go down. Okay, that's why it is unregulated. Okay, that's it, guys. Okay, one more time before we will go for tonight. I will try to plug this one. Okay, so the primary side is energized, and again, the voltage goes up to 21.75. And like what I said, okay, even though if we try to remove the power on the primary side, there will still be a residual voltage on the secondary due to this electrolytic capacitor. That's why I'm telling viewers not to touch the terminals of an electrolytic capacitor if you are not sure that there is still a residual voltage. Because if the capacitor is a very high voltage capacitor, like on the primary side of the power supply, the primary side for power supply is around, the voltage is around, for switch switch mode power supply, the voltage might reach 400 volts. So just in case you happen to touch the 400 volt terminal, you'll get electrocuted. Okay? Okay, this is now for tonight. This is Professor David J. DelosReyes. This is the concept of the unregulated power supply that I assembled, showing you the power output to be 21.76 volts. Okay, good morning from Los Angeles. This is Professor David J. DelosReyes.